Take an example so that we can understand this. And whenever there is an infinity coming into picture, you have to rewrite in terms of a limit, because that is the standard procedure. Infinity you remove and put r here, but r is nothing but infinity. So therefore you have to say that r tends to infinity, which is nothing but limit r tends to infinity. We can evaluate this, e to the power of minus st divided by minus s between the limits 0 and r. We are now asking the question, where is the Cauchy criterion coming into picture in our calculation? The answer is, it is in that place you have to do this. So we will say that this condition has to be applied at this particular stage. So let me erase this, and then for this let me do the calculation here. So the quantity is that just you have e to the power of minus st. That's the only quantity which is present here right now. So that should approach 0. So that should approach 0 like this. I am not saying that this will always tend to 0. That will not happen. We are asking the question whether it tends to 0, like that you are asking. When this should happen? So in case if t tends to infinity, I want this quantity should approach 0 when it is possible. That's the question. This is a plus ib or x plus iy, whatever it is. If you want to write x plus iy, it's okay. So what is x plus iy? That x plus iy is the complex s parameter. So that's what we want to check. And what about this quantity e to the power of I? Whenever e to the power of I, this minus is not important. Plus or minus anything is okay. Whenever you see e to the power of I and there is a modulus, then its value is 1. So this quantity is 1. And then this is already a positive number. E to the power of minus anything is a positive number. So there is no meaning for putting modulus value. The purpose of putting the absolute value is to convert the negative value to the positive value. E to the power of that is already positive. Therefore, we can now say that this is nothing but e to the power of minus xt. So e to the power of minus xt. That must be approaching 0 as t tends to infinity. So I'll erase this. Now what does it mean is that this is anyway 1, not a problem. So e to the power minus xt should approach 0 if x is positive number. So I'll write down if x is greater than 0. So provided that x is a positive number, t is already positive number. So these two are positive, means this minus will be minus only. So e to the power minus number will go to slowly 0 exponentially, it will decay to 0. That's what you understand. That's what yesterday I told you. Whenever you see x here, remember that this is real part of s is greater than 0. So that is what you are now putting the condition. So this is your conclusion from the Cauchy criterion. We have started with Cauchy criterion, and now we got a conclusion. Provided that real part of the s parameter is greater than 0, then only then the integral can. In all other cases, integral diverges. That is the meaning. So now we will come back to this step, because we are now proceeding further. We have done the integration here. This integration and the next step, whatever you are going to do is valid if and only if real part of the s parameter is greater than 0. If it is not greater than 0, all the steps that you are going to write down is simply invalid. Remove this. This one we can now simplify. Then minus 0 when I substitute, I get a 1 here. I am taking the limit of r tends to infinity. So you put the limit and then evaluate. This is equal to 1 by s. But now you have to make a conclusion. There is one result here, there is one result here. So it is not, you have done two different steps. This gives you 50% of the answer. This gives you 50% answer. You have to merge these two and then write the final answer. Okay, so usually we say that just a Laplace transform of 1 equal to 1 by s and then close the matter. You forget about this. So I am trying to explain you. This is what I am telling, that analysis. Analysis means you think and analyze when the quantity 1 by s is valid, when it is invalid. 1 by s is completely invalid if real part of s is either equal to 0 also invalid. It should be greater than 0. That's the point. So it should be greater. In case if it is negative, also invalid. So provided this condition is there, only then this Laplace transform exists. In all other cases, Laplace transform does not exist for this one here. Like this, the conclusion comes. And if you want to draw a graph, you can also represent or depict this in a graphical style. How do you do that is, you simply draw a complex plane like that. So this is a complex plane. Why do you want to draw a complex plane? Because S is a complex parameter. This S has a real part x plus iy. So real part of the S parameter is on the horizontal axis, and on the vertical axis you will be drawing, or it contains the imaginary part of the S parameter. When you draw that, the real part of the S must be greater than 0. So where is 0? This is 0. So this point 0 should be excluded. There is a 0 here, it has to be excluded. Only equal to 0 is not there, no, so I have to exclude. Then all greater than 0 value should be taken. So only the condition, you see, this is important. The condition tells you only on the real part. What about imaginary part? Imaginary part doesn't participate in the condition. Imaginary part can be anything, can be 0, minus, plus. It doesn't come into picture because the modulus value, it has gone to 1. So that is the reason. Imaginary part can be anything, but real part is very important. Where is imaginary part? These are all imaginary part. These are all imaginary part. Because this is imaginary axis, imaginary axis. What about the real? Real should be this side and that side. So this is positive real side, negative real side. Positive imaginary, negative imaginary. Imaginary can be anything, so let us not worry. Real part only should be positive. So this is the positive side. Therefore what you do is, you simply draw. I'm actually putting shade, okay. If you have the color pencil, you can give a nice color this side, and then that is a shading I am trying to give in such a way that all the positive part of the complex plane is shaded. I am giving some color or something like shading. I have to draw it carefully in such a way that this should not touch the y-axis. You see, I am drawing, but then it should not touch the y-axis. Why it should not touch the y-axis is because this is greater than 0, not greater than equal to 0. If it is equal to 0 means each one of the line can touch the y-axis. It should not touch. So therefore, the entire right side of the complex plane, in this entire plane, the Laplace transform of 1 converges. That means the Laplace transform of 1 exists here. This side and the left side, okay. On the negative side, Laplace transform of 1 does not exist. That is the purpose of the Cauchy criterion. So now you understand what is the purpose of the Cauchy criterion. We will be able to tell the region of convergence. This portion that you have written like that, this is known as region of convergence. ROC means region of convergence. For every problem, that means for every problem like this, Laplace transform of e to the power at, Laplace transform of cos omega t. For any of these problems, whenever you do the calculation, you have to first find out what is the region of convergence and then show it as a diagram. Okay, whether it is on the upper half of the plane, this is upper half of the plane, this is lower half of the plane, this is the positive side of the plane, this is negative side of the plane. So depending upon the problem, some portion will be valid region. So if the region of convergence is discovered, that has to be shown graphically, and it will be existing in the shaded region. This quantity doesn't exist, Laplace transform doesn't exist in the unshaded region. Usually what happens is in the textbook, okay, because you may be referring to many textbook, they will write like this: Laplace transform of 1 equal to 1 by s, comma, the condition will be given like this, s greater than 0. Subject to the condition that s greater than 0. Like that they will give the condition. But if that kind of condition is given, you have to assume that in this case, when somebody is telling that only s is greater than 0, then the person who is telling, I mean the author of the book, is going to assume that s happens to be real quantity. So I told you that what I told in the last class is the s is in general complex. In general complex means in particular it may be complex for some problems. For some problem, s may be real, or in some other problem, s may be purely imaginary. Real part is totally not there. So problem to problem situation can change, but in general, s is a complex in nature. You may have a real part and imaginary part. So this will take care of everything. real and imaginary. But here you are already assuming that it is valid only for real, which means that this result is invalid, or we say that in case if you are going to complex domain, we cannot apply s greater than 0. So that is a point you have to be careful. So this is much more stronger condition, because this takes care of both real and imaginary part, because s happens to be complex quantity. So I am giving this point because in many of the textbook you will be finding this kind of condition there. This is one thing. Second point, that at the same time you have to remember that you can ask the question, what happens if s is 0? Okay, if s is 0, then this quantity itself is not valid. So what happens is, therefore s should not be 0. You don't have to tell separately s greater than 0 like that. You don't have to tell, because already real part is greater than 0. Even if the imaginary part goes to 0, real part will take care that this fellow will not go to infinity. 1 by 0 will never happen. So therefore this condition is, additional condition is not required, because this will automatically take care of the 1 by 0 also. So that is all about it. Once this is clear, then we can follow the same idea for the remaining problems, and therefore we can do it at a little faster speed so that we can get the answer.